Okay, welcome to the stream, guys. Hello. It's me back again with more lead code questions. This is the best, right? Okay. Cool. Okay, let's get started. Yep. Hopefully my stream is up, which is good. Yes, my G. Okay. Let's do the daily question today, which is this. Divisible and non-divisible sums difference. You are given positive integers n and m. Define two integers as follows. Num1, the sum of all integers in the range 1 to n, both inclusive that are not divisible by m. The sum of all integers in the range 1 to n, both inclusive that are divisible by m. Return the integer num1 minus num2. The sum of all integers in the range that are not divisible by m. Okay, so isn't this just a for loop? Isn't this just this thing? Lalit Wasabe, keep up, bro. Yes, sir. Yup. Okay, we messed up. What happened here? Num2 is sum of all. Oh, sum. So we need this plus equals I. C1 plus equals I. Yeah. Sorry, I just got a message on my work email. Let me just do that. Okay, so this works. Let's get back on to need code. I was on greedy problems. Merge triplets. Yeah, I never did this one, right? No, I did. Okay, I'll do this again. Reset this bad boy. So, KCPS. Okay, so I wanted to do this question again because why not? Okay. Sorry about this. Let me just do that. Boom. Okay. Perfecto. I swear to God, this was zoomed in. How do I zoom this back again, man? How do you zoom in? Yeah, code editor. Font size, let's do 18, brother. Nice. So in merge triplets, a triplet is an array of 3 integers. You are given a 2D integer array triplets where triplets of I is A, B, C, describes ith triplet. You are also given an integer x, y, and z. To obtain target, you may apply the following operation on triplets any number of times, possibly 0. Choose 2 indices and update triplets j to become max of this, A, B, C, and C. If this is this, okay, return true if it is possible to obtain the target. So the point in this question was we only need those triplets which are lesser than target, where each number is lesser than target thing. So that is the only trick this question needs. Harish, hello brother. So the point was for okay, vector int t in triplets are they all positive? Yeah. If t 0 is less than target 0 and t1 is less than target 1 and t2 is less than target 2, then only this is we also need equality. Okay, now here what we can do is res equals max of t0 res 0, and we copy this 2 more times. This will be 2. This will be 1. And at the end, if res is equal 0 0 0, then we say false. No, we just return res equals target. Okay, why is this so bad? Oh, instead of doing max, we can just do equality. Yeah, that's fair. That's fair. Yeah, but it's the same concept, so it's fine. So, oh shit, I need to sign in here also. Let me just do this. Sign in. Boom. Oh, it's basically converting English to C++. Yes, kind of. I mean, this is a tricky one. I mean, if you don't understand what this guy is asking, you can get into a rabbit hole, which will be very bad in an interview. And yeah, LeetCode stats are just so random, I guess, but not this much. I mean, if it is clearly very bad, then it is probably bad. So you might have to look into the best one. But since the approach is same, so it's fair. Okay, so greedy problems are done. That's a good news. Great. I was doing intervals. Okay, merge intervals. Let's get it. Given an array of intervals where intervals of I is start I and I, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So this might not be even sorted, right? It's not sorted, right? So we need to first sort it. Let's take this example. My eyes. So the point here is we start from here, right? First of all, we have to sort this thing based on the start of I. So this seems sorted, but what if start of I is same? Then what we should sort with? Yeah, we should probably sort with the ending of I also. So one first here will be sort intervals dot begin, intervals dot end, compare start then end, and this comparator will be, how did I write a comparator for a simple array? Is it a struct like this? And then we do operator overloading here. A const vector int b return if a of 0 is equals b of 0, then return b of 1. Sorry, a of 1 should be greater than b of 1. Otherwise, return a0 greater than b0. Right? Should I just define this in this class? Is that what you're trying to say? Does not refer to a value. What? Have I fucked it? I might have. Oh, it's just a bool function, man. We don't need struct. We need struct for, I don't know, for priority queue. I don't something like that. Compare interval. It's just this, man. Right? Is it? Non-static. Okay, I think I messed up. I sorted in the opposite order, so this should be this. This should be this. Yeah, now this is fine. Okay, we have the sorted thing. Now what we need is we need to merge these guys. So I start from here. I can push this in a resulting array like here. Let's say I pushed 1 3. Then I check if result.back is overlapping with the next one. And overlapping can be simply how do I check an overlap? Now I'm very sure that this let's say this is A B C D. I'm after sorting I'm very sure that A cannot be greater than C, right? A has to be less than or equals to C. So I can simply check if this guy C is in between these guys, then it is overlapping, right? Right. So if C is in between A and B, then there is an overlap. That's all I need to check. So let's see here. Int result dot push back intervals of 0 for int I equals 1 I plus n. If is overlap result dot back intervals of I, then result dot back of 1 equals max of and also I know that B will be less than or equals to D, so I'm pretty sure I just simply do this intervals of I of 1. Otherwise result dot push back intervals of I, return result. Let's see some of these. Intervals is at least of length 1, so this is fine. 0 and 10 to the power of 4. Let's see if this works. Shit. Bool is overlap vector int A vector int B. You know what? Let's do const return B0 A0 is less than or equals this, and B0 is less than equals A1. Okay, so the sample test case is passed. Let's see. Oh, it's wrong, brother. 1 4. Yeah, makes sense. Shit, didn't think of that. Max of result dot back 1 and this. Let's see now. Didn't think of that, brother. Okay, it is pretty slow. Why is that the case? Merge start end if merged is empty, or merged back 1 is less than start, merge dot emplace back this, otherwise. Yeah, pretty much the same thing, right? I don't know why. Yeah, it's fair enough. I mean, it's acceptable. Even sorting with this is enough, I believe. So if I do this, I think this will be also correct. Yeah, let's see if there is any timing improvement, time complexity. So yeah, very significant. Okay, so the time complexity of this will be, since we are sorting, it will be n log n, where n is the number of intervals in the input, and this is just order of n, so that's all. And space complexity is also order of n, because we are storing it in a different thing and returning it. Perfect. Non-overlapping intervals. Given an array of intervals where interval of I is start I and I, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Note that intervals which only touch at a point are non-overlapping. For example, 1, 2 and 2, 3 are non-overlapping. Okay. Return the minimum number you need to remove. Okay. So I can do the same thing. Instead of merging them, just skip over those, and that'll be it, right? So first we sort. Okay, minimum number of intervals. Okay, so let's see here. Now there can be many cases in this. Now for example, let's say we have 1, 2 and 1, 4. Not even 1, 4. Let's say this is 1, 2 and we have 2, 3. So this will be the sorting order, right? And here we have 3, 4, and then we have 4, 5. Now here, since this will be the sorting order, if I keep 1, 4, then I see that this is overlapping, so I skip it. I skip this one. Then I see 3, 4 is also overlapping. I skip this one. Okay, this is fine. But if I don't include 1, 4, I skip this one. This is fine because this will be the first one. This is also fine. This is also fine. So minimum it will be answer 1. Okay, Okay. So is this a DFS question? Dynamic greedy sorting. Yeah, seems like it. So at every interval, I have an option. Either I can include it or remove it, right? If it is overlapping with the next one. Yes, right? Okay, so I have an option at 1 4 to include it in the result or not include it, right? If I include this, then I skip all of these three guys. But if I don't, I mean, then it'll be fine, right? So as a dummy interval in the result, I can keep 0 0 maybe. But yeah, start I and I can be these, so it is negative. Damn, bro, have I done this before? Yes, I have. Let's see, what did I do here? Okay, sort, then we have a stack st.push for int I equals 1. Previous is this, current is this. If current 0 is less than previous one, then there is an overlap. Then st.pop overlap. If current one is less than previous one, st.push current. If current one is less than previous of one. Oh, we are checking if like 3 is less than 4, then it is better to push 3 because there will be more window to spare for the next intervals. Yeah, that's a fair greedy approach. If there is an overlap, then we pop that guy. Then yeah, if current one is less than previous one, then push current, otherwise just keep previous, that's all. Else push current when there is no overlap, and then at the end intervals dot size minus st dot size. Fair? That's a fair assessment. Yeah, we could use stack, but yeah, this will also give the answer, but it will be expensive for sure. Yeah, stack is a good approach. Okay, let's do this. We have a stack of vector of int, call it st dot push intervals of 0 for int I equals 1, I is less than intervals dot size I plus plus vector int current equals intervals of I st dot top. If current of 0 is less than previous of 1, then there is an overlap condition. If this is the case, then st dot pop first of all, and then I check if current of 1 is less than previous of 1, then st dot push current, else st dot push previous. When there is no overlap, just push current. At the end, we simply say return intervals dot size minus st dot size. Interesting. Oh, I didn't sort. Okay, let's do a sort. Compare intervals, const vector int a, const vector int b. If a 0 equals b 0, then return. Oh shit. Compare sort intervals. So the time complexity is n log n, same as before, but it seems bad. If I don't include this, I think this will be fine again. If I don't do this, let's see. Yeah, I think it'll be fine. Yeah, slightly faster. What is a faster solution? Vector pair. Yeah, that is more intuitive. That is more easier to understand, so I'll stick with this. I will stick with this. Cool. Meeting rooms. Oh man. Given an array of meeting time interval object consisting of start and end times, determine if a person could add all meetings to their schedule without any conflicts. Oh, I just have to check if there is any overlapping thing. Is that all? It's not considered a conflict at 8. Okay. So I can simply do this static bool compare I it's the same deal, man. Oh, my bad. Sort if intervals of I minus 1 ending time is intervals of I starting time is less than the ending time of the previous meeting, then return false, otherwise return true, right? Is that all we need? No. What? Oh, shit. Oh no, man. What a load of shit is this? Bro, it's an interval object. Interval. So if instead of this we just do a dot start is equals b dot start, is that it, or this? I think dot should work, man. Yeah. Cool. Is that it? Oh, that's all. Great. Let's get back here. Let's find if this is in. Okay. Under subscription. Yeah, I see. I see you. Given an array of meeting time interval object consisting of start and end times, find the minimum number of days required to schedule all meetings without any conflicts. Okay, now this seems interesting. Okay, 040, 510, 1520. So 510, 1520 can be scheduled other day. Yeah. Okay. Interesting. Should I be scheduling all the biggest meetings first and then do the rest of it? Does that make sense? I mean, it doesn't really matter, but still, I'm thinking like if I schedule the most time taking meeting on the first day, right? Yeah, I should first of all sort them based on start time and end time also, because then I'll know like which meetings will occur first in the day. So okay, if I schedule a meeting on the first day, then that is done. I don't need to take care of any of those, right? Yeah, I think I can do kind of an n square loop, and that will give me the number of days, and keep a done array where it tracks if this meeting has been scheduled or not, and I need to keep track of how many days I am scheduling those meetings. I'm thinking kind of like that. Yeah, that can be done, I believe. An n square solution. Yeah, intervals is 500, that's why it is n square. Okay. First of all, let's store this guy. Right. Let's also create a boolean vector, done, of size same, false. Represents if a meeting has been scheduled or not. Now for interval m in intervals, if not done, if done m, oh, I need the index, man, shit. Int I equals 0, I is less than n, I plus plus. If done I, then continue, otherwise interval current equals. Intervals of I. Now I need to schedule it, so before scheduling it I need to check if there is a okay, let's sort these guys. Okay. Static bool compare I const interval a const interval b if a dot start b dot start, then return b dot end, otherwise return a dot start is less than b dot start. Sort intervals dot begin intervals dot end compare I. Perfect. Okay. If this current meeting overlaps with previous, how can I check that? If the start time of current is less than prev dot end, if current dot start is less than end of previous, then we can't do this, right? But if it is okay, then we can't schedule it here, right? But if it is greater than or equals to, then it is simply, yeah, continue, man. Despairs. Continue is pretty bad in programming, but still, I mean, it's fine, man. Fuck it. Then prev becomes current and done of I becomes true, right? And at the end, if prev.start is 0 and prev.end is also 0, then return. Okay, days equals 0. So when I start, return days. Expected 3, 2, 1. Okay, I'm increasing them. Okay. Interval prev 0. Okay. If all of them are done, yeah, days should be 0. But if they are done in the first day, then previous will not be that thing, right? Yeah, it starts with 0. Let's see if submit works. Yes, brother. So only thing here is it doesn't say how good your solution is. So it's kind of an n-square approach. Two pointers, min heap, n log n, sweep line, n log n, 2 pointers. Greedy. Okay, let's watch this guy. Let's watch on YouTube.
Hey everyone, welcome back. Let's write some more neat code today.
Bro,
so today
stop.
let's solve meeting rooms 2, and just like
Why
meeting
it is
rooms
flickering?
1, we're going to solve this problem on the
Bro,
website
get to your
called
homepage.
because
Practice.
this is a premium leetcode problem, so if you want to be able to solve it for free, you can use leetcode.com. So it's pretty similar to meeting rooms 1. We are given a list of meeting times. Each meeting time is an object, and it has 2 variables. It has a start time and it has an end time. And the end time is always going to come after the start time. That's pretty intuitive. And we want to know what's the minimum number of conference rooms required for all of these meetings. Now, what they actually mean by conference rooms is basically what is the maximum number of overlapping meetings at any given point in time. So for example, in this input, we have a meeting that starts at 0, ends at 30, another meeting that starts at 5, ends at 10, and then another meeting that starts at 15 and ends at 20. And we would need 2 meeting rooms for this problem because we are going to have 2 overlapping meetings. So if we had one room where the 0 to 30 meeting is going on, the 5 to 10 meeting is basically going to be going on during the same time as this one. So we're going to need a second meeting room for this. And we also have another meeting 15 to 20. Now it doesn't overlap with this one, so technically they can be a part of the same meeting room. Now we don't actually need to determine what goes in each meeting room. We just have to know what's the maximum number of overlapping meetings at any given point in time. In this case, that happens to be 2. We are going to be required to sort the input array, which is going to take n log n time complexity. So this is going to be the time complexity of the algorithm. The memory complexity is going to be big O of n. I'm going to show you how to do the solution. Now, if you just stare at this, like the problem statement, and just look at these numbers, it's going to be difficult to come up with how to code the solution. But as you guys know, I like to draw pictures, and when you look at the picture, it actually becomes pretty easy to figure out how to solve this problem. So let's do that. So this is kind of how we can visualize those meetings, right? These are the exact same meetings that we were given in that first example. We have one meeting going from 0 to 30, another meeting going from 5 to 10, and another meeting going from 15 to 20. Now, if we just go from left to right, we're going to see, okay, well, this is the first meeting that starts, right? It starts at time 0. And if we just keep going, now we see what's the next point on our grid, right? Well, there's another meeting, and this is not an end time. This is not, the first meeting isn't ending. There just happens to be another meeting that's starting. So another meeting just started at time 5. So what does that tell us? That tells us 2 meetings have started so far, but nothing has ended, right? There's no meeting that's ended yet. So at this point in time, we're going to have 2 meetings going on at the same amount of time. So what we're going to be maintaining is a variable count, which tells us at any given point in time, what is the number of meetings going on. And right now our count is 2, and we're going to end up returning whatever the max value this happened to be. So what's the next point on our grid? We visited this one, we visited this one. Now we're looking at this one, right? Okay, at time 10, there's an end point. This is not a starting value. This is a starting value. This is an ending value. So what does that tell us? That tells us a meeting has just ended. So what are we going to do with our count? We knew we had 2 meetings going on at the same time over here, but now after this point, we're only going to have 1 meeting going on, right? Like look at the picture. There's only 1 meeting going on, and it's this first one, right? 0 to 30. So we're going to set the number of meetings going on to 1. Now we're going to look at the next point in order. Now it happens to be a start time. So another meeting just started at time 15, right? So once again, there are 2 meetings going on, right? At this point, there's 2 meetings going on, the first one and the second one. So once again, a meeting started, that's going to tell us to increment our count. So now we're going to say 2 meetings are once again going on. And again, we're going to repeat the same process. The next point is at 20. This happens to be an end time. So that means a meeting is ending, right? We don't technically even know, is it this meeting that's ending or is it this meeting that's ending? It doesn't really matter to us. All we know is that after this point, only 1 meeting is going to be going on at any particular time, and it's going to be this one. So we're going to take our count of meetings going on, decrement it, and now it's going to be 1. And last but not least, we're going to go to the last point in our grid, and it's also a end time. Obviously, the last point is always going to be a end time for a meeting. So that means another meeting is stopping. After that point, there's only going to be 0 meetings going on. So therefore, we can take our count, decrement it all the way down to 0. Now we notice that what was the max value that count happened to be? Well, the max it ever reached was 2. So therefore, we're going to return 2 as our result. 2 meeting rooms is enough to contain all of these meetings. Regardless of if it's looking at the that they're meeting time, if we do as well and sort of, we're going to have 1 pointer at the beginning of start and 1 pointer at the beginning of end. We're always between these 2, we're always going to pick the minimum value. So we are going to maintain a count, which tells us the number of meetings that are going on. And if the minimum between these 2 is the start time, what we're going to do is we're going to increment the count of meetings going on and then shift our start pointer to the next one. And we can see that that's the case again, right? 5 is less than 10, therefore a meeting has to start before this meeting ends. So once again, we're going to shift our pointer over here and we're going to increment our count by 1. So the count is now going to be set to 2. And now we get to the edge case, right? We got a tie. So a meeting is ending and a meeting is starting. Remember, we are going to visit the end time if there's a tie first. So what we're going to say now is that, okay, a meeting has to end before this meeting starts. So we're going to shift our end pointer to the next one. If we iterate through an end value, that means a meeting just ended. Therefore, we're going to decrement our count by 1. So 2 is decremented by 1. It's going to be set to 1 now. Now, again, we're going to compare these 2 values, 10 and 15. Which one is smaller? The 10, right? So therefore, another meeting is starting. So we're going to increment our count by 1. So count is now going to be equal to 2. And now we don't even have any start times left. So technically at this point, we're just going to be iterating through the end time. So we're literally just going to be decrementing this. So we iterate through this, decrement this down to 1, iterate through this, decrement this down to 0. So technically, once we've gotten through all start times, we don't even have to iterate through the remaining portion of end times. So what we can say is that our max count at any given point it reached was 2. So therefore, we're going to return 2. So that is basically the algorithm we're going to use. And coding it up isn't going to be too difficult. Yes, we are going to have to create 2 separate arrays, start and end, and we're going to have to sort these input arrays. So
Okay, I got it. Yep. Hello, brother. How are you? I'm doing good, brother. Subedara, what's up? Okay, so neat code is suggesting to keep start and end times in separate arrays and then go along with that. Okay, let's get that done. So, that was fair. So, okay. So up until here it is fine. But after that, we just need to erase start time of size as interval, which is n. Or I don't even need to do that. I can simply push back. So for vector of int I in intervals, start time dot push back I 0 and end time dot push back I 1. Now pointer, let's say I is at 0 and j is at 0. I will point at start time and j will point at end time. So while I is less than n and j is less than n, if start time, okay, we see concurrent count, max count. If start time of I is less than n time of I, then concurrent count plus plus. Also, if they are equal, n time of j actually, if they are equal, then concurrent count minus minus, else if it is less, then plus plus. Okay, I should have seen code also, like
And don't forget, we are going to sort it, so I can do that. This is going to be the position we're at in our start array. E is going to be the position we're at in our end array. And I'm basically just going to keep going while S has not reached the end of intervals. Also going to do the else case, because if they're equal, then we want to make sure we increment our E pointer first, our S pointer, and we're going to be incrementing the count, so we do have one additional meeting going on right now. That's what we're saying. And after every iteration, basically, we're going to update our result potentially. We always want it to be the maximum that we've reached so far for count, so we're going to just take the max result. Once that is done, that means this loop, once this loop is done, that means we've finished all of our start times. So at that point, we can basically.
okay.
Return our result to be ensured that it has reached whatever the maximum is going to be. And with all that, we can go ahead and submit it. Hopefully this works. And as you can see, it does. It's about as efficient as you can get. So this is the.
Okay, while start is less than this, if starting of S is less than ending of E, then S plus equals 1 complement. Else, okay, this is easier. If start time of S is less than end time of E, interesting. Oh, ah, ah, oh, no. What? I'm writing in the wrong thing, man. Shit. Oh no. Okay, yeah, let's write this in here. So we probably don't need these. We don't need this. Okay, so we need vector of int start and end for. Okay, it says it is accepted. Let's try to submit. Okay, it works. It works. So, all right. I think this will be it for today. I'll be back tomorrow again. I will try to be consistent with leetcode, man. It's just, I mean, I don't know. I'm just too lazy, man. Fuck this. Okay. So, yeah, I'll make sure that I'll be back tomorrow for at least an hour again. Until then, GG's, have a good day. And I'll see you tomorrow. Bye.